Now we move to our next speaker, who is Hambardzumyan from YerevaNN. He will talk about coding practices in deep learning. Karen, please share your screen.
Okay, wait a minute. Please confirm that you can see my screen.
Yes, it's okay.
Yeah. So, first of all, thank you, Arsen, for a great talk. It was very informative. So, my name is Hambardzumyan, and I'm a machine learning researcher at YerevaNN. And today I'm going to talk about some good coding practices, especially for deep learning, but it is not only limited to deep learning. I think that these ideas can be very easy to generalize in other fields too. So the reason of this talk is that there are many, especially in data science and machine learning community, many people don't understand, and they really underestimate the value of the code quality, and they don't understand that there are several things that can help actually to develop them their code more efficiently. And especially for data science, there are like many differences from like traditional software engineering, which like make clear for me that not only we need good practices for data science and machine learning applications, but instead we may even need some better tools, better debugging and coding techniques to overcome these issues. For example, one big problem is that if your model doesn't work, if there is a bug somewhere in your code, in your model, it is often that you'll get no errors. While in software engineering, when you have a bug, like mostly always you'll get an error somewhere. And also in data science and especially in deep learning, we experiment with models that are mostly black box, that are practically impossible to interpret and to debug, while in software engineering there are rule-based code for humans, by humans, so it is very easy to debug. And also one interesting thing, in software engineering, engineers spend most of their time on R&D, but like in data science, as far as I know, like people spend more time on debugging and investigating why the model doesn't work. Like they spend 70% of their time and only like 20% of time on actual coding and developing their models. And also counting the fact that they are mostly compute heavy long running programs in these applications, we need to think of best, like good practices to avoid any bugs. So data scientists tell that what we want to prioritize is the speed of prototyping. But I will not agree with this, because the first priority can never be speed. When I listen to something like this, I remember one of my favorite memes. Like I think that the first priority is correctness. You have to be certain that your model works correct. That's your first priority. And there is like they are chasing for speed. They are like this need for speed approach is not working, especially in long run. And after a week, after a month, you start to realize that your code is so difficult to add, to change, to make new experiments, that it becomes a disaster. And we'll talk about some good practices, and I hope I'll manage in time. I will make sure that we're on the same page. Say we are talking about especially deep learning stuff, and I recommend you to like stick with Python 3.6 above because they have like all the features at least mentioned in this talk. And also, I hope you know how to use version controls, for example, Git properly. Also, it is very important to know how to like work efficiently on a project, and one of these ideas is to work remotely, especially when you are doing a deep learning stuff, because in many models, like you want consistency, and you can't even sometimes run the model locally and test it. So it is better to have a unified environment, unified way to testing and developing and training, and also doing anything or like everything remotely guarantees that like even when your laptop is closed, your code is working, so you can train models. But when I say remote development, some people may think of Jupyter notebooks, but Jupyter notebooks are not fun. Like actually, they are fun at first, but they're easy to use for iterative development, for testing little code snippets. But after some time, they are starting to collect many code, and this also brings to very bad things. And like I think that we should know how to use Jupyter notebooks, and we should know that Jupyter notebooks are supposed to be like for analyzing. And I recommend you never train any network or do like your development and use Jupyter notebooks as your primary development environment. And please check out this link. I'll post it in the Slack. Also, remember, IDE is your best friend. Like IDEs can help you find errors even before you see it, like even before you realize it, or even before you run your code. But it is like there are actually a couple of very good IDEs. For example, one of them is VS Code, which is free, in fact, and this actually supports both remote development, and also it has integrated debugger. And it is very cool because, like, if you are using VS Code, you're guaranteed to to have like remote connection and remote development environment in like 3 or 4 clicks away. So here you can see that it is very straightforward to open, to run it, and also it provides you some good quality linting. It warns you about that W variable that you not used, and also it does this kind of type inference. Type inference is also very important because it helps you to autocomplete correctly, not like it is done in Jupyter notebooks or what. And also, I want to mention that it has like a very good debugger, so you can always debug. And the good thing is this can be also done remotely. So right now, locally, I'm debugging my code in the remote computer on our servers, and I want to also to note that this code is PyTorch, which is in fact my next slide about. I want to recommend you to use PyTorch and or other dynamic graph libraries. After trying one, you'll understand that you'll never go back to static graphs. Unlike static graphs, they are more intuitive and have natural way of programming the control flow. They are they have more human readable errors and can be easily debugged, as shown in the previous slide. And you can also mix Python code with it. The thing is, in static graph, in TensorFlow 1, you had to encode and wrap sounds like in some way your data in order to pass it to the model. But it is not a case for PyTorch. You can pass absolutely anything. And I'm not the only person in this earth admiring PyTorch. And I think that actually the PyTorch is great, and it is especially great because it helps you to debug and find your mistakes much faster. Okay, another thing I want to talk about is using higher level machine learning frameworks. Please do not write your custom training loops. You don't need it because I doubt you need some custom behavior that can be coded in higher level machine learning frameworks. And as you write more code, more boilerplates, it is turning much likely that you made newer mistakes. And I want to also mention that there are actually pretty good frameworks. PyTorch Lightning and AllNLP are my favorites. We use PyTorch Lightning in YerevaNN primarily, and we use AllNLP in our NLP experiments. I really like AllNLP. It's and they are well crafted. They have well crafted abstractions. They come with many models and methods out of the box, and they handle training, saving, logging, loading, testing, the command line interface, hyperparameter search, and anything. Like, they're handling it for you. What you need to do is just write the code you need to write, the core logic of your code. So if you just you are using a custom model, then fine, you can define the custom one. Even if you want custom training loop, you can even customize that part. And suppose you are already training networks using these higher level abstractions, and say we have such code. This code doesn't represent anything. It may work, but we can't understand anything about it. And what to do to make this more maintainable and more understandable? Like the thing is that maybe you know what this how this code works, but maybe like after 1 month of vacation you'll forget it. So please make your code readable, even if you are not working with a team, or even if you are not going to publish it anywhere. Please make it readable for you. So one way to make code readable is inserting comments, but I've seen many places when people just add some bunch of comments, but it is not the best way. There's a better way. At least here, we can see that all the variables are like 1-letter variables, which is like the worst practice I've ever seen in data science, and I'm continuing to see it again and again, especially in some tutorials for beginners. So it is like the worst thing to see. The naming of variables is very important. I don't mean just picking any other name. Pick meaningful names that can represent the meaning of your code. For example, here I've removed all the comments, but my code is more readable because here we can see that the input is tokens, and we just want to embed all the tokens. And after that, we got a mask. We encode it using the mask. And after that, we have pulled version of that encoding, and you can see then in the next lines that the next lines are using the exact pulled version of these embeddings, and this line clearly represents that this the output of the projection layer is not softmax but is logits instead. So this is like hidden layer without softmax on top. So comment your code only if it's complicated and has non-obvious parts. And another thing in Python is type annotation. And this may be weird for many people because people like Python for its dynamic behavior, and many people may not understand what's the idea behind annotating our code. Especially here, I have annotated the types of my inputs and the outputs of this method. What's the reason why we want to do this? If we annotate a type, we can use type checking and autocomplete, which is actually a great thing to do. It helps you to remove like 50% of any errors, like even before like running your code. For example, here, as we have type annotations for our forward method, we know that the out is a dictionary of some tensors, and as the loss is a tensor, the IDE suggests us some tensor methods. And also, if I try to use like a type which will not run correctly, it warns me even before I run my actual code. Like, imagine this code is somewhere in your code after the training phase, so you are waiting like 10 hours your training to complete, and after that it drops you, it raises an error about type. So it is better to IDE to warn you about this error even before you've got some errors. So about shapes. Shapes are a great way to annotate the type of tensors, because in this case, we have like only input and outputs as different types, and all the rest are tensors. And how to annotate them correctly? It turns out if we annotate tensors with shape, it will give you so much information. For example, see here, this annotation is like, this suggests us that the embeddings is three-dimensional input, and also this mask is two-dimensional, and also that the first axis is supposed to be the batch size, and the second axis is supposed to be the axis, the variable axis of our text. By the way, this is a classifier, like regular classifier for text. And you can even start to understand something that you never know. For example, suppose you didn't know what the puller is, or maybe you didn't know. Anyway, here you can see that we have an encoding, which is a batch size, num tokens and encoding dim, and here we have an output as batch size and encoding dim. So this pulling, this operation, we already made it obvious that this operation is supposed to get rid of this variable axis and get an sentence embeddings, like instead of sentence word embeddings. So another good thing is that you can mix your Python code with your tensors. For example, here I recommend you to return multiple things from your model. For example, here you can return both the logits, for example, and the probabilities. And in many cases, I've seen people try to do to measure the loss outside of the model, but handling the loss within the model makes it easier to manage everything. For example, here we can have just one forward call. This is, by the way, inside of our forward call. If the label are given, we are calculating the loss, and as our return value is just a dict, we're just adding loss term to the dict. And it is common convention in higher level machine learning frameworks like PyTorch Lightning and now NLP that they use this loss term of output dict as something they want to optimize. And you can pass metadata as the output can be arbitrary number of outputs of any kind. Input can be too. And sometimes it is better to have also non-tensorized, like non-preprocessed versions of raw data or the metadata. Suppose you have like some kind of error, and you have like this tokens index with tokens tensor, which is, by the way, two-dimensional matrix of indices. It is not human readable, right? So what we can do actually, we can during the debugging, we can look at the other parameters that are given us. For example, here I set up my dataset reader to also pass raw tokens and raw premise and raw sentences as my input. Here you can see my my labels and okay, I actually like right now tokens here are only IDs. So without these raw representations, it is very difficult to actually debug. And also you can one good thing is to always to append here to provide also some metadata. For example, which sample is that, like unique ID of the sample or the file and the line number where the sample came from. Also, very important thing is backward compatibility. And if you don't want to, say do a git commit after every single change in your code in order to like make your code reproducible, you can do this. Say for feed-forward layer wasn't there, and right now we want to add this. But instead, I'll recommend add that optionally. So if like initial configuration or command line argument is given to turn on the feed-forward layer, then we'll turn it on. And by default, we will turn it off. So this does mean that by default, this code is equivalent to the code in the previous one without like before the change. So we can do this. We can have like we can train a model like the first command line, and then if you change the model and we now want to train a model with feed-forward layer, we can do the second command. And when we go back to the third command, here what we can see that this third command works exactly as the first command, even after the code was changed. So it is very important. So about docstrings. Docstrings are not that important for us, at least for in cases if we have like some prototypes. But after your code matures and you start using them in every single place of your project, please make docstrings, because even if you are, I repeat, even if you are not working with a team or if you are not going to publish your code, after 1 month of vacation, you are most probably like you'll forget what is your code is about. And here is an example of code string, docstring. Docstrings actually provide you lots of information. What are the inputs and what are their purposes, and also what are the types and their shapes. Also, draw a model. This is my favorite part. When you're drawing something, you start to understand it much better. It is like when you're studying something, when you write it down, you start to understand it better, right? It's the same thing here. When you start drawing, you start understand different parts, and you start to notice like different details, and this helps you a lot. For example, this diagram not only clearly shows the separate and shared layers, but also states recurrent operations and all the shapes. So I strongly recommend to draw your architectures like this to better understand your model. And there are some debugging tricks. Ranjan, how much time do I have? Okay, let's continue.
We have 2 minutes, but we have break next, so we can.
Okay, I'll try to use another 5 or 10 minutes. So about debugging, there are some tips and tricks of debugging. First, I want to be cautious with these dynamic graphs, because when you're debugging these graphs, they are sometimes lazy. So you're not seeing what is going on there. Just turn off this lazy mode. This lazy mode is turned on by default to provide you insane speed, but you don't need them for your debug mode. And also, please watch NVTop. This is especially good tool in order to see your GPU utilization. If your GPU utilization is lower, then it means that you have some bottleneck in your code. And also, you can use profiler, especially the pipe instrument is a good one, to find the parts of your code that are working most slowly. And also, if you have shape annotations in your code, you can also check if it corresponds to the real shape while debugging. You just can print the shape, where's the shape, while debugging step by step. And you can also do sanity checks, especially, for example, you can do like, you can always create a smaller model and train it like 3 or 4 steps in the beginning of each training phase. It helps you to find your errors like much faster. And many of these high-level libraries provide these capabilities of sanity checks. And there are also a couple of things to note. I recommend to log everything, log losses, all the metrics, and everything possible in every n step, like including the step 0. Step 0, I mean, even before the training was started, because at that step, your model is completely random. So it is very useful to compare your model with the random one. When you log everything, you can do debugging after even your training was completed. I don't mean like literally everything, but if there are like some numbers, you can like write it down to log it. It will be good. Also, do not print anything. Like, I mean, it is 2020. Use loggers. When you do loggers.warning or loggers.info, it will not only print your message, but it will also print where that file was. And also, it will also print the timestamp of that exact moment. And that is very useful. And also, please log, please store all the logs in some central location and use proper software to deal with them. About reproducibility, this is very important. And when training models, you always want to be able to run your older models, compare them, or build a new one on top of them. Sometimes you mess up your project and want to return to a place, to a state where your models are working, right? So reproducibility is like a very important part, especially for if you are doing experimenting. And there are tricks to have this. First, write backward compatible code as possible, as much as possible. Also, use Git. Even your code is backward compatible, you'll unintentionally break it someday. So use Git, commit after each significant change, ideally every day. And have a requirements text. Please do have requirements text. It's very useful. I repeat, you are not doing it for your teammates. You are not doing it for GitHub community. You are doing it for yourself, for future yourself. You also want to make sure that your code base is deterministic. So like every time you run the code, you get the exact same results. For that, you have to seed. But the problem is that there are many places to fix the seed. There is Python seed, Python hash seed, NumPy seed, PyTorch seed, and even there is QDen and non-deterministic algorithm that you should maybe disable, but at least that one is not that that's a problem. So you can leave that on, but the other ones, I strongly recommend you to fix them. So also, all the data, checkpoint, log, and metadata directories should be unique and immutable. This is important because when you are giving someone or writing down some path, you want to make sure that that path will not going to be something different in like 10 days later. So this may, you may think that this may like will become bigger and bigger. You can actually remove these large files, but don't remove directories and the metadata inside it. What do I mean by metadata? All the data directories should include a config or log of where the data came from and how we pre-processed and selected that data portion. And also you want to have like unique directory for each run, for each trained model. And for that directory, inside that directory, you will save your logs, your metadata, your hyperparameters, your checkpoints, your TensorBoard logs, etc. One example is here, like we are participating in WNT20 biomedical competition this year, and this is an example of our directory. This directory contains all these big files, but it also has this pre-processing log file. This is not actually config, but it also has this config. So this log file contains the exact config how it is made. So like 1 year later, I can open this file and see how that was done. This is actually very important. And your code should have one configuration, like it is like combine arguments in Lightning or just a JSON configuration file in ONNLP. And you want to capture all the environment variables and also git commit, because you want to report in which state you have run that exact experiment. And yeah, store it in a central place and use proper tools to read the logs. So this is something that I found after our intern I've done pre-processing, and after it was like after 2 weeks later, I opened this pre-processing file and noticed something weird here. These percents of unknown words are very high, and this suggested us that we've done something wrong. And after that, we found it, we fixed it, and now it is like working properly. And maybe it will take so much longer time to find that bug if we don't have these kind of statistics, logs, and like metadata in our directories. And I also want to know that when I save everything, I save literally what I can in my logs. But yeah, there's something, sometimes it becomes messy to play with. Yeah, and however, there are some tools. I know that as far as I know, it is today. Someone is going to talk about MLflow. Please join the talk. It is a good tool to store your experiments. And also there is an AIM tool. This is like basically right now MLflow plus TensorFlow, but this has like a very cool killer feature for me. This like this also allows you to group and filter things, and this can make your experiments logging much easier. So to recap, please follow the coding guides, use IDA features, use like it is must. Use high-level frameworks, please, and write code for humans, for yourself first, and know that reproducibility is crucial. And by doing it in the right way, you can have a guarantee that it is reproducible. And log everything, because like reading logs will help you a lot. And also use right tools. Okay, thank you. Maybe we'll start a question answering.
Yeah, thank you, Karen. I think this was quite informative. We don't have right now questions at Q&A window, so audience, please, if you have a question, write it there. And I think Andranik has questions, so Andranik, let's...
Yeah, thank you very much, Karen. I have lots of questions, and I want to reiterate that these things are actually very important and very useful, particularly for beginners. If there are any in listening to this talk, do this, and months or years later, you will just thank Karen for saving you a huge amount of time. I have a bunch of questions. First of all, CUDA and seeding. Does CUDA always respect your seeding? I think I've seen some libraries you try to force the seed and they have internal randomization, and at least at some point there were some big issues with speed also. Like if you force the seed, certain things also run very slow. What's your experience on this?
Please let me find that. Okay, so the problem is that there are different parts that we need to seed, but there's one particular part that is CUDA-NN. Actually, the CUDA, as things stated in their documentations, they have actually their design. They are designed to be deterministic. As long as CUDA-NN is not enabled, it is the first one. And also, please don't forget that if you are using a consumer GPU, it doesn't have those memory checking places. So you will end up with some kind of like non-deterministic behavior when using not Tesla GPUs. So, but what I want to say, even with this cuDNN, it is like this difference is very small, because the majority of difference, like in especially in deep learning, comes from how the data is shuffled. Like it depends on data shuffling seed, and also it strongly depends on the initialization. So like in the other part, for example, like some operations are not that like non-deterministic. Like even if there is a like small amount of how it's called schalang
yeah, error.
yeah, if there is an the error, if there is an error, that then there is a very little one. So I've actually I always leave cuDNN turned on, because it actually turning it off yeah, compromise lots of performance. But
so another question regarding the long training and debugging. One common practice is to have a very small data set on which you just do a sanity run to make sure that we don't get that 10 hours wait, and then but what has happened, like what I have seen in my practice is sometimes there is an error which happens, let's say, on the second epoch. So with a small file, okay, first time you increase the number of epochs for 2 because you save a file, and then on the second iteration you have forgotten to do it properly, so it tries to overwrite, and then there's an exception. And then sometimes the first 2 iterations are not enough to see any tendency in error or something, so you need. So what's your experience in sort of balancing this sanity check run while keeping it reasonable, sort of not going from 1 minute to 10 hours, but what's a good threshold cutoff in this regard, trade-off?
so basically in deep learning, like in both in research and development, in both cases, we use lots of custom things, right? So did this lead to such scenarios that like maybe even like 70% of my mistakes may not ever happen to you. So what we want to like discuss, we wanted to discuss today is what some general checks can be done to overcome these issues. So yeah, I like there's always a mistake that can be like found before you actually run it. And what I basically do is I insert lots of asserts in my code. I have like 2 modes, like debug mode and not debug mode. If it is in the debug mode, I just try to do lots of asserts. For example, I assert say shapes, and so but it is not always a good idea to do this assert, because it will like make your training slower, because this lazy mode will be automatically turned off.
Okay, so 2 more short questions. So first of all, any drawing tool that you can recommend? And another one is about requirements, text and conda. How do they? I mean, I personally have not been successful in making them work together. So you know.
So the same with it is the same thing with me. I have not the ideal recommendation, but instead I definitely recommend to use Conda, because Conda is not only a Python package manager, but instead it's like package manager for OS, for your like user place. For example, I don't like doing sudo install something. I always like install with Conda, and Conda also brings with himself all the even native C++ libraries that are required. And the best practice to use Conda is first you install all the required packages using Conda, and after that, if there are left any packages that you can't find in Anaconda repository, then you can install it with pip. And it is like the best practice will be have both environment YAML and requirement.txt. Requirement.txt should like state all the packages required, and this environment YAML should like state all the versions, exact versions of exact repositories, what to download from Conda or what to download from pip. So concerning to the first question, actually I use different drawing software in different cases, but mostly I use this service called Draw.io. Maybe they, as far as I know, yeah, they changed their name, diagrams.net, and basically this website, and they have also an app, has lots of diagrams and templates that you can use. Actually, unfortunately, there is no like diagram template library especially for neural networks or machine learning like pipeline elements. But I hope one day someone will do that.
I had a tiny hope that you would say that there is a library that you give your model file in Python and
there is actually,
diagram, but
yeah,
they don't look.
Yeah, they don't look good. I mean, it is possible only for, say, static graphs, because all the dependencies, and especially it is good for higher level static graphs. For example, in Keras there is a method, I guess, which like returns you a kind of a diagram which contains all the connections, all the dependencies, and all the shapes and all the numbers of parameters. It is very handy actually, and I used to be using it a lot. But in these cases, I mean, it is absolutely not possible to throw in like a good way to do it automatically. And also what I recommend to do is to draw it yourself, to start to understand all the details, because during this drawing you start to notice very, very tiny details. And it is the same with implementation. Well, I tell all my students to go and implement some like known models and methods in low level, so they can really understand what they are working with. And after that, I have a very good feedback that this really helped us. We understood that we have no idea how the model worked before actually implementing it. And it is like similar to drawing your models, and it is, as I said, similar to when you're like, say, learning something else than mathematics and machine learning. Say something else, and you start to write down, you start to understand, you start to like remember many things. So even if you can find automatic drawing tools, please do it yourself. It will help a lot.
Thanks a lot, Karen. Actually, I mean, we could talk about these topics, I think, for a long time, but maybe we should take it to Slack, because I see that we are already have eaten into much of the break. So, Rand?
Yeah, there is one question from Rafael Darpignan. Let's quickly answer that and then move on to the break. He says, what do you think about pipenv? Why not use pipenv instead of conda?
Why to use a pipenv instead of conda? That is my answer.
Okay.
There is. I think that conda, at least conda, is not package manager for Python. It is package manager for everything. So you can like install any libraries. For example, I hope you are not, but if you want to install, for example, RStudio, you can conda install RStudio. It is just for example. Don't do that, please. But the point is that this conda not only like installs everything, not only brings the dependencies, but also has ability to resolve the dependencies. It is not done right in pip. So pipenv is like, yeah, pipenv is good because there is no underneath question is not will not raise ever if you use pipenv, because there is no conda and no pip. But yeah, using conda is much better, especially if you are using some libraries that have native bindings.
Yeah, just to add in this regard, conda will know and pull processor optimized math kernel libraries when you are installing something like NumPy or scikit-learn and these higher level things which are maybe good for other types of projects. Conda resolves so much of that. You can just do conda install PyTorch and it will install PyTorch and pull YerevaNN. And doing that by hand for TensorFlow, which was the case for a couple of years ago, that was a nightmare.
Yeah. Actually, you if you want to pip install, say, PyTorch, you have to also install CUDA, right? If you want to install a CUDA, you have to have a root permissions, which I also hope that your administrator even give you. So don't please do it in your user local environment, everything.
Great. Thank you, Karen. We have a lunch break now, and we will resume at 2:30 p.m. with David Kocharyan's presentation.
Sorry for taking too much time.